All right, welcome back to Algebra. We're going to finish off section 10.2 then with one last topic. And the problems you see written down the left-hand side of the screen at first don't look anything like what we've been doing for the rest of the week. We've been counting things in a whole variety of ways, and now what I'm asking you to do is take a binomial, x plus y, and raise it to different powers. If I choose my laser pointer here, raise it to the first power, second power, third power, fourth power, fifth power, sixth power, and of course we could keep going if we wanted to. Now, this is usually a little more impressive. I try and mess with you guys a little bit on this one. But I'm going to try and do a bunch of these problems without showing you any of my work, just doing them off the top of my head. Now, of course, the first one everybody knows because anything raised to the first power is just itself. So x plus y to the first is x plus y. Now, x plus y to the second means you multiply it by itself. So technically what I'd want to do is write out, I'm going to erase this in just 1 second, but what I'd really want to do is write out x plus y times x plus y and FOIL those fellas together. But I want to not have to show you all of that work, so I'm just going to do it in my head. And it would then be x squared plus 2xy plus y squared. All right, x plus y to the third, again, without writing it all out, just doing it in my head, would be x to the third plus 3x squared y plus 3xy squared plus y to the third. X plus y to the fourth is going to be x to the fourth plus 4x to the third y plus 6x squared y squared plus 4xy to the third plus y to the fourth. And then x plus y to the fifth would be x to the fifth plus 5x to the fourth y plus 10x to the third y to the second plus 10x to the second y to the third plus 5xy to the fourth plus y to the fifth. All right, and if you trust me, I don't have those written down in front of me. I was just able to do those off the top of my head. Now, if you guys want to pause the video, do you guys see a pattern going on there? Do you see a pattern on how we can go from x plus y to the first to x plus y to the second to x plus y to the third to the fourth to the fifth? All right, well, again, if you want to pause and investigate a little bit, can you see a pattern going on? But I'm going to try to help everybody out. I'm going to slide the screen off to the side before I come back and do x plus y raised to the sixth power. So I'm going to slide this off to the side, and I'm sorry you're not going to be able to see it, but what I'm going to do is, if you're writing these in your notebook, now what I'm going to do is I'm just going to write down the coefficients on the variables. So without worrying about the x's and y's, just write down the coefficients. So on that first one, x plus y, the coefficients would be 1, 1. For the next line, x plus y squared, the coefficients would be 1, 2, 1. For x plus y to the third, the coefficients would be 1, 3, 3, 1. For x plus y to the fourth, the coefficients would be 1, 4, 6, 4, 1. Just jotting them all down. And for the last one that I've already done, the coefficients for x plus y to the fifth were 1, 5, 10, 10, 5, 1. Now some of you have probably figured out why I'm writing this in kind of a weird form, kind of a triangular form, because there's actually a pattern. Every row starts with a 1 and ends with a 1, and then the numbers in between are found by adding the two numbers from above in the previous row. So as an example, 1 plus 2 gives us this 3, or 2 plus 1 gives us 3. If I keep going, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Every row starts with a 1, ends with a 1, and then to get the numbers in the middle, we add the two numbers above. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. So with that pattern, every row starts with a 1, ends with a 1. Can you guys get me the rest of the numbers in the sixth row? Well, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6. And of course, we could keep going to the 7th row and 8th row and 9th row as far as you wanted to. And that allows me, if you noticed a bit of a pattern, to now back up and show you how to raise x plus y to the 6th power without actually writing it out 6 times and doing all the multiplication. The 6th row is going to start with a 1. Then the coefficients, in fact, let me just get rid of the x altogether. Then we're going to have a 6, a 15, a 20, a 15, a 6, and a 1. But what's happening with the variables above? Well, notice the first term, x to the first, x to the second, x to the third, x to the fourth, x to the fifth. It's just the first term in the binomial raised to the power. So I'll start with x to the 6th. And then notice what happens as you go down. Let's say I take the 3rd row. In the 3rd row, the x's go from x to the 3rd to x to the 2nd to x to the 1st to the x to the none. So if I do that same thing, start at x to the 6th and go down, I'd have x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then x to the none. Right? And if you look at the other rows, the x's do the same thing every single time. And then what happens to the y's, the second term in all of the binomials? Well, we start off without any y, and then the y's go up by 1. So as an example, if I go across the 4th row, I don't have any y's in the first term, but then I've got y to the 1st, y to the 2nd, y to the 3rd, y to the 4th. So for us in our 6th row, we'll start off with no y's, and then go up to 1, 2, 3, 4, 5, and end up with 6. And if I switch to red just so I can highlight something, pick any row you want. Let's just go across the 4th row as an example. So I'll highlight that in red so you can see which one I'm looking at. Okay, look at the 4th row. Please notice what you get when you add up the exponents in any one term. Add up the exponents, add up the exponents, add up the exponents, add up the exponents, add up the exponents. You always get the power that we started with. In this case, in terms of the 4th row, we always get 4. And now look down at our 6th row, add up the exponents on the x's and y's, and what we'll always get is 6. So as an example right here, 5 plus 1 is 6. 4 plus 2 is 6. 3 plus 3 is 6. 2 plus 4 is 6. 1 plus 5 is 6. Plus, of course, the first term has x to the 6th, and the last term has a y to the 6th. So all the terms have powers that will add up to the power that we started with. Okay? All right. So this arrangement of numbers has a special name in mathematics. And this arrangement of numbers is called Pascal's triangle. Pascal's triangle. Pascal was a French mathematician, and he kind of developed this arrangement of values to help us with several problems. And of course, you might be thinking, well, the one problem is raising a binomial to the powers. Power of 1, power of 2, power of 3, power of 4, 5, 6, 7, 8, 9, whatever the power might happen to be. But the reason we're bringing up this subject here is because this Pascal's triangle actually has applications to counting. All right, which of course is what we've been doing for the remainder of the chapter. It has applications to counting. Alrighty, and so what kind of counting? Well, Pascal's triangle can help us count whenever we have a situation where our events are called binomial. Where our events are called binomial. And what binomial means is that there's two possible outcomes. All right, there's only two possible outcomes. Not 3, not 4, not 5, but 2. And some examples of things that are binomial events are things like flipping a coin. When you flip a coin and catch it, it can only come up heads or tails. So it's called binomial. There's no other choice. Rolling a die, if you have a game of Monopoly and you take a die out of there, that's not binomial because there's 6 possible outcomes. But whenever there's only 2 possible outcomes, it's called binomial. Another one is gender of a baby. Okay, when a mom and dad have a baby, the gender is binomial. The little one is either a girl or a boy. There's no other choices. All right, can't be a Labrador retriever. It must be either a girl or a boy. Those are the only choices you have. Okay? And Pascal's triangle can help us count the number of ways in which binomial events can occur. Excuse me. As an example, if I were to take 5 coins, balance 5 coins on my hand and flip all of them and let them land on the floor, in how many different ways could they fall? How many different ways could the coins fall? Well, if you consider coins can either come up heads, I'll use H for heads, or tails, I'll use T for tails, sorry. What's the largest number of heads we could possibly have on the coins? Well, obviously 5 of them. If all 5 happen to turn out to be heads, we'd have 5 total heads. But we could also, of course, have 4 heads, or 3 heads, or 2 heads, or 1 heads, or 0 heads. What would be the corresponding number of tails? Remember, we're only flipping 5 coins. So if 5 of the coins come up heads, 0 of them would be tails. If 4 comes up heads, 1 would have to be a tail, and so on for all of the different possibilities. Okay? Now what I'm going to do is I'm going to include, just going to back up and show you quickly. There it is. So I'll circle it up in red. I'm going to show you or highlight the 5th row of Pascal's triangle. So if I drop down the numbers 1, 5, 10, 10, 5, and 1. So let me drop those down for you guys into our, there we go, into our coin problem. So if I drop those numbers down, 1, 5, 10, 10, 5, and 1. That row of Pascal's triangle gives me then the number of ways in which any of the events above could occur. And what I mean by events above is, in how many ways could we have 4 heads and 1 tail? Our answer is 5. How many ways could I have 2 heads and 3 tails? The answer is 10. How many ways could I have 0 heads and 1 tail? The answer would be, I think I said that wrong. 0 heads and 5 tails, the answer would be 1. All right? And as an example, if you wanted to see one of these, I'm not going to list them all out, but how many ways could we have 4 heads and 1 tail? Well, it could be something like this: heads, 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 tail. Or we could have heads, 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 tails, heads. Or heads, heads, tail, heads, heads. Or heads, tails, heads, 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 or finally tail, heads, 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 heads. So you can see that we have 5 options for how we could flip 5 coins and get 4 heads and 1 tail. All right? So it's kind of a neat way to do some specific types of counting. Again, anytime we have a situation where we have a binomial event, we can use Pascal's triangle to calculate the number of ways in which that could happen. Now, if everybody was in class, what I would ask you guys for is a family that has a large number of brothers and sisters. And what we could do is then calculate the number of ways in which that number of boys and girls could occur. In the past, we've had families with up to, I think, maybe 8 kids. So if we were to do an example of a family with 8 kids and calculate the number of ways in which they could have boys and girls, again, the idea would be to count the different number of ways in which we could have 8 girls, 0 boys, 7 girls, 1 boy, 6 girls, 2 boys, and so on. Okay, there's all the possibilities. And then if we could use find the sixth row of Pascal's triangle. That gives us the total number of ways that any of those events could occur. So I tried to leave myself a little bit of room on the right-hand side, because what I'll need to do then is get to the 8th row, because we have 8 kids in this family. We'll need to get to the 8th row of Pascal's triangle. So I'm just going to start blasting through them again. Remember, every row starts with a 1 and ends with a 1. And then we get the number in the next row by adding the two numbers above. Again, just pick one of these. 4 plus 6 is 10. 4 plus 1 is 5. Add the two numbers above. So let me keep going. So this next one, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, end with a 1. And then my next row would be 1, 7, let's see, 21, 35, 35, 21, 7, and 1. And then finally the 8th row would be 1, 8, 28, 56, 70, 56, 28, 8, and 1. And now if I pick up those numbers and slide them into my problem with 8 kids, the family with 8 kids, the numbers again are 1, 8, 28, 56, 70, 56, 28, 8, and 1. And now we're able to count the number of ways in which any of these situations can occur. Pick whatever you want. 6 girls and 2 boys. That could occur in 28 different ways. 1 girl and 7 boys. That could occur in 8 different ways, and so on. So it gives us another way in which we can count. Okay? So I'd like to finish off with just an example or two that'll help you do your assignment. Okay? And so I just need to finish with 2 examples. We'll pick one that's relatively easy, and then we'll get to one that's a little bit tougher. So let's take a binomial, but instead of x plus y, let's pick something like x plus 2. And let's raise that to the 5th power. How are you guys going to be able to do that without writing x plus 2 out 5 times and performing all the multiplication? What I want you to do is take the 5th row of Pascal's triangle. It's only going to take me a minute to get it off to the side. Okay, so here's the 5th row of Pascal's triangle. And what we're going to start with, in fact, maybe I'll get rid of that equal sign so I have a little bit more room to work. Yeah, there, I'll have a little bit more room to work then. Okay, what I'm going to do is start by spreading out those numbers. 1, 5, 10, 10, 5, and 1. Okay? And then what I'm going to do is I'm going to start with the first term in the binomial, x, and I'm going to start by raising that to the 5th power. So x to the 5th, and then as I go term to term, that power just goes down. So from x to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st, and if you want to include this, to the 0. Then we go to the second term in the binomial, a 2, and we start that off at the 0 power, and that one has to go up. So 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, and finally 2 to the 5th. Again, please notice the sum of the powers. The sum of all of the powers in any one of the terms matches up to 5. And now all I'd have to do is simplify. What's anything raised to the 0 power? 1. So in that first term, I'd have 1 times x to the 5th. In the second term, what's 2 to the 1st? 2. And 5 times 2 is 10, x to the 4th. In the third term, what's 2 squared? 4. And 10 times 4 is 40, x to the 3rd. In the fourth term, what's 2 to the 3rd? 8. And 10 times 8 is 80, x squared. In the fifth term, what's 2 to the 4th? 16. And 5 times 16 is 80, x. And then finally, in the last term, 2 to the 5th is 32. And x to the 0 is 1. So 1 times 32 is 32. And we have the product of x plus 2 to the 5th. And a lot of times, this is called a binomial expansion. That's what it's sometimes called, is a binomial expansion. we're taking a binomial, a binomial and raising it to a power. Okay? And I just wanted to finish off with one more. There's just one other thing you guys have to be aware of, and that is when instead of a plus in the middle, it's a minus in the middle. So what if I were to have something like x minus 3 raised to the 4th power? There's just one little adjustment that you have to make. It's not a big deal, but you still have to adjust. Because the power is a 4, we'd need the 4th row of Pascal's triangle. So again, I'll just quickly get that off to the side. Right, so there's the 4th row. We start by writing down those coefficients, 1, 4, 6, 4, 1. We start with the first term, x, raised to the 4th power. And then as we go term to term, those just go down. So x to the 4th, to the 3rd, to the 2nd, to the 1st, and if you want to include that, x to the 0. Now here's where it changes. The second term, when it's a negative in the middle, we don't just think of it as being 3. We have to think of the second term as being negative 3. So we have to start not with 3 raised to the 0, but negative 3 raised to the 0. Then negative 3 to the 1st, to the 2nd, to the 3rd, and to the 4th. Again, please notice the powers all add up to 4, the power that we started with. Okay? But again, using your calculator or just do this in your head, anything raised to the 0 power is 1. So 1 times x to the 4th is 1x to the 4th. Negative 3 to the 1st is negative 3. So 4 times 3 is negative 12. Please notice the negative there. Negative 12 x to the 3rd. Negative 3 squared is positive 9. So 6 times 9 is 54 x squared. Negative 3 to the 3rd is negative 27. So 4 times negative 27, see, I think I'm doing that okay in my head, is negative 108x. Again, please notice the negative there. And then negative 3 to the 4th is 81. So 1 times 81 would be 81. Okay, and that then again would be the binomial expansion. All right, so that's the end of section 2. I know that was kind of a long one, but keep working on that one. Let me know if you have questions. I'll try to help you out. And we'll hopefully get to see you guys soon. All right? Hope you're having a good day. Bye.